Nuclear chemistry, note page 5, transmutation. Transmutation is just another word to represent a nuclear reaction. It is the change of a nucleus of one element into the nucleus of a different element. The result of a transmutation or every nuclear reaction is because there is a change in the number of protons in the nucleus. And if you remember, if you change the number of protons, you change the identity. When a transmutation occurs, it always decays, or another word for decays might be falls apart into a more stable element. It's more stable because the new proton to electron or proton to neutron ratio is 1:1 or close to 1:1. So the stable element, it has a proton to neutron ratio closer to 1:1. Okay? Transmutations can be subclassified into two major categories: natural transmutations versus artificial transmutations. So natural transmutation happens with unstable atoms, okay? Always with elements with an atomic number greater than 83. So one example would be uranium-238. Its atomic number is larger than 83, so it is definitely unstable. It is radioactive, okay? And when its nucleus falls apart, one of the things that leaves or separates from the nucleus is the alpha particle. That's the scary stuff. That's the radiation that people are scared of. But once when the alpha particle leaves the nucleus, a new nucleus, so this would be the new nucleus, and it's more stable than the original nucleus. So I'm going to write original here. So notice, we're going to use the idea of conservation of mass. The total mass on the left is 238. The alpha particle takes 4 of those AMUs with it, so the new nucleus's mass must be 234. On the left-hand side, the total number of protons is 92. The alpha particle takes 2 of those protons with it, so the new structure must have the other 90. And if you go to your periodic table and you find atomic number 90, you will see that the new nucleus form belongs to an element with the symbol TH, which is thorium. Natural transmutations include the following. These are the 3 types of transmutations that you will need to be able to classify or write the reactions for. They are known as the alpha decay, the beta decay, or positron decay. And for all of these, this is where one of the places that you need to use table N. And notice the natural transmutations are named for the decay mode. So these are named for the decay mode. So once again, you don't need to memorize these because you can find them on table N, and you can also find the name alpha, beta, and positron on table O. Versus on the other hand, okay, artificial transmutations. These do occur with already radioactive unstable isotopes, but since they're artificial, they can also be forced to occur in stable atoms. Okay? Since it's artificial, I want to put the word forced. This is more of a forced process. So they require some sort of high energy particles to begin the reaction and bombard the nucleus. Okay? So we have nitrogen 14. And if you notice, this has a 1-to-1. Sorry, I'm going to rewrite that. Okay, so this has a natural 1-to-1 ratio. So this is a very stable nucleus. However, notice that there is a second formula being shown here, an alpha particle. This is that high energy particle. This is what is used to bombard N14's nucleus. And so the N14, it absorbs one of these bombarding particles, and it's forced to change its identity. And so we're going to just use the idea of total mass on the left equates to total mass on the right. So total mass is 14 plus 4, which gives us a mass of 18. And then you have atomic number 7 plus an additional 2 more protons. So now the new atomic number on the left. And if we go to the PT, I think we find atomic number of 9 tells us that it's a fluorine. So this is where the nitrogen is forced to absorb an alpha particle into its nucleus and form a different structure that we know as fluorine. Now, so let's see, we've got a little typo here. So we should have the word artificial. Transmutations include the following, and there are many different types of artificial transmutations. The two you need to know and be familiar with are fusion. And with fusion, we tend to associate that with the H-bomb, the hydrogen bomb, and fission, the other big one, and that would be the atomic bomb, would be the big association there.